We're going to get going here. All right, welcome to the Global Math Department, everyone. My name is Lee Natero, and I will be your host tonight. Tonight, we're going to be hearing from Mindy Adair about promoting mathematical literacy, what our students need to know, why they struggle, and how we can help. Would everyone please introduce themselves in the chat window? I know some of you already have, but if you could tell us what you teach, where you teach, and what your Twitter handle is if you have one, we'd love to hear from you. I know we definitely have people from all over the globe tonight. I've seen people from India and Canada and Nepal and the Philippines and North Carolina and Texas and Pennsylvania. We are definitely a global math department this evening. So welcome, everyone. Before I introduce our speaker, let me explain how these meetings work. These meetings are recorded and are available within 24 hours after the meeting ends. To view the recording, you would use the same URL you used to get here tonight. The global math community prides itself on being friendly and supportive. Chat room is available for topical and general conversation throughout the meeting. I'll catch your questions for the presenter, so don't worry that the presenter won't notice your question in the chatter. Tonight, our speaker is Mindy Adair. Dr. Mindy Adair is the Director of Mathematics and Technology Integration Specialist at Denver Academy. She received her BA in Mathematics from the University of Colorado and MA in Education Administration with a professional principal license for the state of Colorado and her PhD from the University of Denver. Dr. Adair has been a high school math teacher for the past 30 years, mathematics department chair, college counselor, and dean of students. She enjoys working with students to help them believe they can do math and appreciates time spent with colleagues discussing how to best learn and teach math. And this year, she is teaching some Algebra 2 honors, and she has probably some squirrely middle school students in her pre-algebra class. Thank you very much, Dr. Adair.
All right. Thank you, Lee. Thank you so much. I appreciate your hosting tonight. And thanks to everybody who showed up tonight. We really appreciate your time and effort to be here in such a busy time of year and an interesting landscape for sure. So thanks for coming. I appreciate it. I just want to point out I'm having a very good hair day, so I hope you've noticed that. And then I also hope you perhaps have an adult beverage or something that you can enjoy as we have a good conversation tonight about mathematics. So with that, let's rock and roll. Our agenda tonight, we're going to kind of look at what our students need to know, why they struggle, and how we can help. And so I'd love to hear from you in the chat. And then I've also come up with about 11 tasks that I'm going to ask us to do. So feel free to get a pencil and paper in the chat, a journal, something to take some notes on. And as you're reflecting and thinking, feel free to share or to have some independent, quiet think time as we go through some of these items tonight. So I really appreciate that. And also a huge shout out to Twitter and the Global Math Department, MTBoss, and some of the other organizations that have helped us to advance our sharing and collaboration as we work to best support kids and teachers. So thank you for being here. I'm looking forward to it. So our first warm up is to reflect on this picture, and feel free to in the chat or in your journal. What do you notice? What do you wonder, and what might you think? So ponder one of those three and feel free to offer your thoughts in the chat. It'll take just a minute. All right, Lee is noticing that the puppy looks sad. I agree. Thank you, Jessica. This puppy's so stinking cute. Wondering what the puppy's name is. He's a lazy sitter. That's his Kermit pose for sure. I wonder if he's thinking about me. That's awesome. That is great. Well, this little guy is my 105-pound Labrador who still sits like that. His name is Bentley, but he's an English lab, so that big blocky head, we call him Bubba. But what I love about this opener warm-up, it is so accessible to students. So thinking about the accessibility of the opportunities we present, there's an easy access point, and I'm also working to build community as we have a conversation, letting you know a little bit about me, but also one of the challenges that we have right now is we're teaching students in person, on the camera, hybrid, virtual, in a variety of ways, is to continue to build relationships. It seems so much easier back in the day, you know, like last year, when we were all in a classroom with our kids and we could nod to a student or pat a kid on the back or give an encouraging wink. Those kinds of things are more difficult now. And so really thinking about how we can do that in a digital or electronic community is incredibly important. This big guy, James asked how big this big fella is. He's 105 pounds and just solid muscle. You'll see a picture of him later. I'm pretty proud. All right, our second one to warm up this evening is just how many. So this is Christopher Danielson, who many of you follow on Twitter, I'm sure, has a book out and does some awesome work. So I presented this to my second graders, super cute in our school, and also our middle school kids. So in the chat, maybe answer how many. Give you a minute for that. All right, we've got some things coming in. 25, 7 with pits, 15, 7 and 1/2, 15 halves. I love it. And so when we think about this kind of exercise, how many, the beauty of what I asked was I didn't say how many of what, right? We talked about how many simply as an open-ended exploration. I could have a student who says 1 jalapeno, or there are 2 halves of a lime. So many tomatoes. I think that's parsley. I think, or how many chip and dip and guacamoles could we make with this? I'm thinking a margarita myself. So again, very accessible for students as we pose these different tasks for them to ask various questions and to offer and share their thinking. So thanks for playing. And then, of course, whenever I go to a restaurant, I sit down and I'm trying to think for myself, too, how many of these Cajun cocktail shrimp were in one particular order. There were 16 in case you were thinking about that. So a good time to think and ponder as we go through. So in the chat or in your journal, in thinking about both of those activities, the puppy and also the how many, how did each activity make you feel? And perhaps were you relieved that those were our openers this evening? Appreciate that, Lee. Easy to do, which is a nice thing as we're tired. Calm and creative. Thanks, James. Jessica, engaged and relaxed. Love it. That's actually what I was going for, so that makes me happy for sure. Happy and engaged. Sad and hungry, Kimberly. Thank you. Simplistic, but accessible. Connected. No wrong answers. Non-threatening. Thank you, Barbara. That is awesome. And as I look at what I could have opened with was what would have happened, how would it have changed our conversation if I said, please prove the following trigonometric identity. Now, some of you in the room might feel like, sweet, let's rock and roll. And others in the room might be thinking, gosh, that's too much. It's in the evening, it's early in the morning from our colleagues down under. And so really thinking about what are the questions we pose and when do we pose them and what's our tone as we're sharing. So thank you for that. Our 3 goals today, we're going to do some maths. We're going to talk about some tasks. I'd like to challenge us to think about our perspectives and messages regarding who can do maths. And then I vote that you're going to leave here knowing how funny I am, because I really think I'm funny. And I told a joke today with my students, and they groaned, but I think you'll appreciate it. It's later in the presentation. So in just thinking about setting up our stage, our biases and our insecurities, we've all been to that cocktail party or event where the question is, what do you do for a living? And whenever I'm asked that question, I get the answer. I mean, I always say, oh, I teach mathematics. And how often do we hear, oh my God, I was horrible at mathematics? And And it's fascinating to me because the reality is we have that response, I would assume, out of insecurity, or perhaps people think they are going to, I'm going to have them do a geometric proof on the spot, recite the quadratic equation. I'm not sure what they're nervous about, but yet we wouldn't say things like that in other venues. For example, we would never admit out loud, I don't think in a social setting, oh, I can't read, right? That would be embarrassing to us. And so I would challenge us as adults, when we're talking to other adults, parents, our colleagues, as well as our students, what we say matters, and it matters deeply. I was at an airport a couple of years ago, and there's a lady at the end of the bar, and she got her tab from the bartender, and she reported very loudly and looked around to share, I'm very good at math and I can do it in my head. And I was just thrown off by that, because I think I'm pretty good at math, but I'm not great in my head. I use paper and pencil. I appreciate my calculator. I'm a slower processor in some ways, and to me, that's not the interesting thing, the speed. But I also was curious. I wonder why she felt the need to share that information. I don't think the bartender really cared, but who knows? So it is an area of our development that we do have our own insecurities, and how we treat those, how we help ourselves to grow, will be important as we move forward. And so thinking about just mathematical literacy, I like the second quote from South Africa. I grabbed this one. It enables learners to develop the ability and confidence to think numerically and spatially in order to interpret and critically analyze everyday situations and to solve problems. And so I think about when we talk about mathematical literacy and we think about what do kids really need to know, I would hope we present them with opportunities to grapple with ideas, to think about numbers and relationships, and then to be able to have creative thoughts about how things are connected. And so as we go today, I would like to shout out and really encourage us to appreciate that mathematics is for all. It's developmental. It requires work and patience and determinations. And what we do say matters, and it matters deeply. And so honoring our students and their differences and their developmental process with mathematics, I think is paramount. And in the chat, some great comments coming. Students not hating math, not fearing math. I think it is our job and our responsibility to help promote mathematical thinking in a good way. And I got an email I'm going to share with you a little bit later. I'll share it with you right now. Right before this, about 5 minutes before this webinar started, I got an email from my student who struggled with math last year. He's in my Algebra 2 honors class. He said, "Hey, Dr. Adair, I found a cool video on a really interesting pattern that I thought you'd enjoy. I put the link in the video so you can watch it when you get a chance." And this is a kiddo, it's, after hours, we had been looking at patterns and visual patterns, thanks to Fawn Nguyen and some of her work. But he reached out. He shared with me that he's found something cool, and he was engaged in the thinking. So I just love that. I appreciated that from my young student. All right, our next task for you to do, this is, I'm sure you all have seen math walks, and it was kind of a lot of folks did this on sidewalks in April and May of last spring when we were all at home. But if you look at these tally marks, I had my middle school kiddos do this last week. I'd love for you to kind of just think about, what do you notice? What do you wonder? And then could you make a set of your own tick marks that follow some pattern? So I'm going to give you just about a minute to think of that. And welcome from the Bahamas. Love it. All right. Awesome. So in thinking about this set of patterns, what my kiddos came up with on the next slide was just super cool and interesting. I thought that it was creative, and it was a class actually where I was in one building, I teach in a different cohort. They were in a room across the campus. And so one thing that I think was super helpful for me as their instructor, I had another adult in the room with them, was to be just real explicit with our instructions for how students can share their thinking, especially in this landscape. So you all are sharing in the chat, which makes me happy. My kiddos, I would ask them to write on a note card and hold it up to the camera so I could see what they were thinking. or whiteboard to camera, pencil to paper, thoughts in the chat. So helping them to know how to share their thinking and collaborate. We also used a Jamboard and Google Meet and did some sharing and collaborating that way. And there are lots of great ideas out there for that kind of collaboration. But so thanks for sharing on that. We'll keep motoring on in terms of thinking about initial thoughts, just valuing student thinking, right? Mathematical content matters and the integrity of the discipline is essential. So how we access it with our kids is really important. And so I think one thing I saw a presentation at NCTM in 2018, and Andrew, I believe it's Gall, talked about this effect where when we lower expectations with lower cognitive tasks, of course performance is going to be lower and so is confidence. So I think it's our responsibility, and at Denver Academy, really, we talk about having high expectations, high accountability with high levels of support. And so helping students believe they can is so important as we do this good work with our kids. And being explicit with expectations is one way to offer high accountability, high support. And one of the things we've done in our face-to-face instruction, which is what we're doing right now, is we have our big five. And my colleague Philippe Nguyen is on the chat tonight, and he loves acronyms. He came up with this acronym of HANDS. Hand washing, sanitizing, 6 feet apart, never without a mask, diagnose at home, and safe culture, to be respectful of others. So what are the expectations we can all agree on so that then we can attend to the other cool stuff that's happening in the classroom? And Lee did a nice job in our intro of setting the stage for how we would interact in the chat and how we would be respectful. And I think that tone is important with our students as well. It is difficult right now to manage everything from kids in person to kids on the screen, remembering to charge your equipment, having the laptops up, the extra monitor, the iPad to track the virtual kid. There's just a lot going on. So when we think about that, then we also partner that with kind of what do our students need to know, and thinking about the content standards, the processing standards, and quantitative literacy, which we'll talk more about. Kind of the content standards, I love this graph from NCTM, thinking about how throughout every grade level, we attend to these different content standards in different ways. I also appreciate the processing standards and thinking we want our kids to continue to work on communication throughout their mathematical journey as they progress through schooling. And then quantitative literacy. All right, our next task in the chat. I have a baby tiny little bottle that I got at a Bronco game. They were giving them away. And the question is, how many ounces do you think the little guy is? How many ounces do you think the big guy is? So let me give you just a moment in the chat to attend to that. All right, see if we get some answers. Great, Lee, thank you for chiming in. We're thinking ounces here. Awesome, Barbara's coming in with a number. We've got a fraction, 2 to 3 ounces for the little guy, 3 ounces, 1.5. Oh, awesome, you guys are awake and with it. And actually the little guy is 1/8 of an ounce, which I found interesting. I don't think it was near enough hot sauce for one meal, but I liked my food spicy. And the big one, I wondered what you might call the big bottle. I think I might call it a party, but I think that was a 12-ounce version of that. So thinking about quantitative literacy, I was super excited to be able to support my wife, who's a marathoner. And at the New York Marathon a couple years ago, I was standing next to this dad, and his daughter said, "Hey, Dad, how fast do you think the elite runners run a mile in?" And the dad said, "Well, I don't know, maybe like 2 minutes." And I was like, "Wait, what?" Like the Olympic guys are like 4 minutes, 4.5. My wife runs like an 8-minute mile, which amazes me. But in thinking about that, I was so stunned by his answer. And yet, if he hadn't seen 20 marathons like I have, he wouldn't necessarily have that context. So that's not necessarily very far off. And what was interesting, you'll see the staple box on the top. The number of staples per strip, I asked my kids the other day, and then how many in a box. And I just did not think they would have any sense of that. And the number in a strip, anybody want to guess number in a strip, number in a box? Yeah, Jessica, a missed opportunity with this kiddo, for sure. Awesome. Lee's chiming in. 1,000 in a box. I appreciate that. All right, how's everybody's beverage? Doing good? Got your coffee down under? Oh, thank you, Kimberly. She did great. She did the virtual Boston this year. And Sue, a dear friend of ours on the call tonight, was cheering her on as well. Yeah, there's 210 per strip, and then 5,000 in a box. And so my kids were amazing. My kids were shooting between 150 and 250 for the strip, and right around 4,000, 5,000 for the box, which just amazed me and impressed me. So super cool to think about when we create opportunities for students. And numeracy is kind of thinking about the ability to make sense of numbers and to use them effectively. So every time we have a warm up, a which one doesn't belong, a how many, an estimation 180, which we'll do later, that just helps kids to think about numbers. And I think one of the cautionary things that I've come up with and is represented here in this quote from Steve Chen, who's a very strong research on students with dyscalculia. Thinking about as students continue to struggle, our temptation as teachers often is to concentrate even harder on narrow range of activities. And narrow range of activities, like are we going to force them to try to master multiplication facts ad nauseum, and then they lose the joy and the enjoyment of mathematics? Or are we going to keep working on those things but continue to move forward with some cool and interesting concepts? So keep that in mind as we look at early numerical development, that ability to kind of link that representation of numerical to the quantity of symbols. And as we watch students who tend to struggle, there's something called a distance effect, where we compare like a 3 to a 5. That's a smaller distance than comparing 2 to 8. So with the larger distance, it's easier for students to have an understanding of that magnitude. And what some of the studies have looked at is just in looking at that with students with different learning profiles, there is a difference in their processing. And so when they looked at kids with dyscalculia and those without, when they did an experiment with what they called a congruent pair, where physically the 3 is smaller and also magnitude-wise, that the two groups weren't very different on, but yet with the incongruent pair, they really were. So creating that opportunity for students to grapple with numbers, to sort things, count things, and have a sense of that really is a helpful thing. And I got this from a colleague of mine, and I asked for her permission to use it, including his face, because this was a Saturday morning at their house. And the picture on the right, the picture on the left just is awesome. He's pensive, he's sorting, he's interested. And I love the one on the right where he just seems proud and he just seems happy that he's done some cool mathematics. So I think in that numerical development, that's really critical as we give opportunities for our kids in our classrooms and at home, the opportunity to think about numbers. We've all talked about, and I think everybody in the call would believe for sure, we can all do maths, and thinking about how do we create those environments where kids are supported and can struggle and it's a safe place. So as we look at that, we want to think about kind of why do our students struggle, and thinking about these 4 areas. Mathematics certainly as a language and discipline is complex. We've got social and emotional components, environmental issues, and then we'll wrap it up with learning profiles and kind of look at some of those as we end. The mathematics as a language, we're going to talk a little bit about conceptual understanding, procedural fluency, and automaticity. And you'll notice my numbering system there. I'm okay. It's 3.14. See what I did there? That was awesome. Yeah, instead of like ABC. You got anybody like that in the chat? Little love. Okay. And we're thinking about conceptual understanding, procedural skills and fluency and application. And I credit my colleague, Veronica Fieldler, for coming up with these logos. But when I think of these 3 things, I think we often flip the order. I think a lot of times math educators think that procedural fluency is at the core, and we've got to master that before we can move on. And yet, steps that kids are trying to memorize without understanding, it just doesn't stick with them. So I would hope that we would think about the conceptual understanding as the key component, and we can build procedural fluency from that conceptual understanding, which is what one of the NCTM practices in good mathematics teaching talks about. As we think about that, I wanted to highlight tonight 3 strategies in these areas, conceptual understanding, procedural fluency, and application, that promote student engagement. And I'm a shout out to the colleagues that I'm going to highlight here. I follow them on Twitter. And I use their materials. The first one is Necessary Conditions. And give me a yes, you've seen this book in the chat. It's been out not too terribly long, a little while, but Jeff Kroll, who I follow on the Twitter, talks about creating that academic safety. And I think one of the things that's critical in that academic safety is really creating those relationships where students can feel supported and respected, and that you respect them and they respect you. A lot of folks in the chat have this book. That is awesome. And thinking about quality tasks, those are the things that are what we often call low floor, high ceiling, where they're accessible to students, where there's an entry point, but yet once a student says, oh, I have a solution, I might say to the student, well, can you think of another one? And so really giving them that opportunity to think beyond what the task at hand. The second one, I'm sorry, I'm going to go back 1 second there. Effective facilitations, I think that's absolutely critical. If you look at master teachers, so when we observe master teachers in action, it's a beautiful thing. It's my analogy is if you watch football, if you like football, when a football game is really well refed, you don't even know the refs are there. The game continues on. And I think this is true with technology and with teachers in the classroom, to have the ability to facilitate a conversation with students where it's their thinking that is highlighted, and you're promoting and supporting and encouraging, but you're not solving things for them. So great book, and Lee's offered, maybe she can get some books for folks in the chat. So that is exciting. I appreciate that. And our next one is Sarah Powell, who was a presenter here 2 weeks ago, a professor at UT Austin. And she did some presentation, and one component of her presentation was on intentional instructional delivery, being intentional. And one of the things I appreciated very much about her presentation was her comments on precise language. I think one of the things we do often with our kiddos is we try to simplify for things and languages, and I think that's a mistake. Her research has shown that when we do that, when we say for a fraction top and bottom, instead of using the terminology numerator and denominator, we're actually requiring kids to learn more vocabulary. And often students with different reading challenges and language development learning profiles, that's like, why are we doing that to them? I also think it lowers our expectations. When we lower what we think they can accomplish, guess what? They don't accomplish as much. So that's important for sure. And I think that it's super cool. I was in my pre-algebra class and we did the whole sets of numbers, including complex numbers. We talked about the square root of -1. Now, I don't think those kids necessarily are going to hang on to that, but they were exposed to it, which I think was super cool. I think we have a chat. We have a question coming in the chat. And so I'll try to catch that as we go. And then our third one is application. And how many of us have seen Open Middle from Robert Kaplinski, I believe is his name? We'll talk about a particular problem here in a minute. I'm going to ask you to do a task in a minute, and then I'll come back to the chat and see if I can answer some questions. But one of the things that I appreciated very much about this strategy was just valuing the journey of thinking. And so really appreciating allowing students to work on the problem. And I will share one of my missteps was a couple of years ago in a classroom. It was geometry honors class, and I had just a great conversation going. Students were working in partners. It was a great task. They were deep into it. It was thoughtful, and it was so awesome. And I walked up to these two young men and I said, "Oh, what do you guys think?" I totally interrupted it. I absolutely got in the way of their conversation. So it's interesting to make sure that we set up the instructions or the stage or the task so that students can find success, but yet then we allow kids to investigate, explore, think, discover. And thanks, Sue. Precise language is so important and absolutely helps kiddos decode higher levels of mathematics. So I'm going to go to the next task we have, and this is an open middle problem. And I'll take a minute, let you guys see if you can find a solution, the digits from 0 to 9 using at most one time each. We want to make these both equations true. And I'll say the top equation is independent of the bottom equation, except for we can only use the digits 0 to 9 one time. So let me pause there. I'll see if I can catch any questions that were in the chat while you guys work on that mathematical task. All right. Anybody in the chat have an answer? Just a yes or a no. They're interesting question, Aaron. While you love open middle, you wonder if it is a learning opportunity and perhaps what those opportunities are. Looks like we have a couple folks in the chat that maybe have a possible solution. Appreciate that. All right, I'm going to continue to move forward, so keep your questions coming in the chat. Awesome. Lee, I had one the other day that I thought I had it, and then I had a repeated digit I didn't realize. So, and then I just said to my kids, well, what if we change the rules of the question? So that's always awesome. Yeah, and so Aaron talks about a student would have to have a good understanding of this concept. And so it was interesting because some of my kids in the class, I think, had a good understanding, but others didn't, but it was an opportunity to review. So I came at it from a different angle, depending on the kids, and it worked as kind of a way to do some differentiation for me with support of my students. So thanks for doing that. I appreciate that. We'll look at kind of the next reason that students might struggle in mathematics, and those might be some of our emotional and social considerations. Certainly mindset, confidence, and some of the motivation components. So we'll take a look at a couple of things. But again, low floor, high ceiling tasks. These are some great ones. Which one doesn't belong? I'm sure you're aware of. Jo Baller has some great tasks on her U cubed. Fawn Nguyen with visual patterns, estimation 180. So some nice ones there for sure. And we'll look at which one doesn't belong. And one thing that I like to do with my students is after we kind of set the stage, give them the opportunity to create their own. So now they're creating some of these which one doesn't belong, and then they do the warm up and share that with the other students. Saw our second grade class, our second grade teacher is amazing. And she loves to do these with her kiddos, and they love to create them. And it's just so cool to see those little guys talking about the numbers and noticing that, more than just 3 is the only single digit, but think about the sums of the numbers. So 1 plus 2 plus 3, 3 plus 1, 2 plus 7 is 9. So what are the other ways that we can think about creating these situations? And then also extending it. We do some work with Orton Gillingham in our students, and we have teachers that use it in a history class or in a science class. So we can always extend and expand how we use some of these tasks. Terrific. And then this is one of my very favorite. I love to play this if you ever need to have a little downtime. It's a bowling. It's in Jo Baller's book, Mathematical Mindset, but I also saw it from Math on the Plains. Dr. Deborah Dougherty presented at Math on the Plains conference. And so bowling, rolling 2 number cubes, and then coming up, we can do this as a class. This was an opening unit for my kiddos in my Algebra 2 Honors class this fall, when I'm trying to get to know them and create that culture of learning where it's not about a race, it's about us honoring each other. And so thinking about how we support that throughout the year. Oh, awesome. Trisha has which one doesn't belong in the hallways with Post-it notes. That's a great suggestion. Thanks for sharing that. And then 4 4s, and this is a cool one, using exactly 4 4s, come up with the numbers from 1 to 20. And it was fascinating. I did this with my middle school kids and then my high school kids, and thinking about, like, once we kind of got stuck with some of the mathematical operations, but like once you add factorials or logarithms, like it just expands what they can do. And so cool for them to do it like in a middle school setting, then after they've learned some more mathematics to see it later in the progression. So I like that one. And there's my dog, Big Bubba, 105 pounds, loving the Colorado winter. But thinking about mathematical anxiety and unnecessary pressure, timed expectations, public situations, kind of lack of confidence. And I share a story that kind of broke my heart. My colleague and dear friend has a daughter in 4th grade, and they do mad minutes for multiplication, factor, subtraction, addition, and every day they record their scores, and this is the paper that gets sent home and the parent has to sign. So in the chat, I'd love for you to think about and share, reflect on what message does this send to the student? Does the message change for various students? How does their identity, race, gender impact either the message they get, as in receive, or the message that the teacher might deliver? So in the chat, let's take a minute here and think about that. And somebody said in the chat, the 4 4s for elementary ed students. Oh, yeah. Sandra did the 4 4s for elementary ed students. That's fantastic. So much rich content to think about. Yeah, low esteem. I also was very intrigued, I thought the other day, in terms of identity and race. I was a Calculus 3 student at a CU Boulder, 500 students in the class. There were only 2 women. And it was just a very interesting. Now, granted, I'm older than most ER, but it was very interesting how just that lens and my identity as a mathematician, like I looked around, I didn't belong. And so what does that say? This gets worse. This student doesn't get to go to recess when they don't pass their mad minutes. So I definitely appreciate there's a time and place, and we do want students to have some automaticity with math facts so that cognitive resources can be allocated for other things. And yet, this is it just crushed my soul in terms of what this kiddo took away. It was interesting, though, last year, there's hope, y'all. I sent her a video, the daughter, a video that Joe Baller did on talking about speed in mathematics, and that speed isn't a definer of one's ability to do mathematics successfully. And she was very comforted by that. So I appreciated that for sure. We'll continue to move forward. And again, the slides are available, so I'm going to skip through some of this research so we can get a little bit further along with some of the activities. But thinking about just the environmental influences, we've talked about parents and teachers' attitude. We certainly want to have a coherent scope and sequence for our curriculum, resources that are helpful. And one of my favorite researchers, Fred Davis, talks about technology acceptance model. Technology needs to be easy to use and useful. Easy to use and useful. And that takes us to kind of thinking about what we say matters deeply. And so either in your chat or in your journal, just think about what are the things that we might say to kids that are either discouraging or encouraging. And sometimes, it certainly is unintended. So I'll let you kind of noodle that out a little bit as we move forward. Some of the things we maybe shouldn't say, it's easy for me. I'm just not a math person. You're so smart. Think about instead saying, help me understand your thinking. I'm proud of your effort. So thinking about how we say things and the tone and delivery is certainly important. That takes us to a quick story about my mom. My mom is awesome. She just turned 80. She's been living with us. She's doing great. But she is not a technology person in terms of her use of technology, has not done a lot. My dad did all that before he passed. But I took her to DC a few years ago to NCTM, and she wanted to go take the metro down to see the museums. Well, that metro map was super complicated. So we went together, we did a dry run, we came back, we had to review our thinking. My mom doesn't drink, but I had a nice adult beverage. And then I needed to modify the plan. And so what I did was I created a map for her, exactly where she got off, when she got on, and that kind of thing. And she said, Nguyen, this is great, but how do I get from the hotel to the metro station? And I was like, oh man, Mom, of course. I had gotten her part of what she needed, but I hadn't scaffolded enough. So on the back, I drew out, from the hotel, she could go around 9th Street to the M Street, and that's where the metro was. So just really think about with our students, what support do they need? What can we do to help them so that they are able to be successful, gain confidence, and be independent with their work in mathematics? My mom made it to the mall, so she had a good time for sure. So just reviewing kind of those 3 reasons that maybe our students struggle. And then we're going to take the next portion of our time together to really think about learning profiles and some of the mathematical learning difficulties or challenges that some of our kids face. And I struggle and grapple, and I've done a ton of reading on research, a lot of my own research. And I think there are some kids who there's a continuum, right? Some kids are challenged in mathematics because maybe it's just developmentally, they're not quite there yet. And so I often, especially with high school student placement in classes, often parents want their kids to be at a certain place at a certain time. And it would be, my thinking is it would be like saying every 2-year-old should be potty trained, walking and talking at the same moment. That's just not how it works. And yet I have not met an adult that can't walk. So developmentally we can get there, but I think unfortunately there's a lot of angst and insecurity because we don't want our kids to be behind. And so I think having an understanding of some of their learning profiles allows us to be more open to the mathematics being a journey. So we're going to go through a few of these, and I've created just some things that maybe can help us as we support students in these areas. We think about kind of the nature of the struggle and looking at kind of the aptitude, maybe the cognitive ability, and what are those data points, and then achievement indicators as ways to access information about students. And the two that we focus on at Denver Academy, we look at the Iowa Test of Basic Skills as an achievement test, and then the WISC-5 for that aptitude cognitive. And that gives us a lot of information in order to best support our students. We're going to look briefly at dyscalculia, dysgraphia, and dyspraxia tonight. And we'll start with dyscalculia and just having an understanding that those are learning challenges with some of the basic arithmetic facts, processing some numerical magnitude, which we talked about earlier in the evening, and then performing accurate and fluent calculations. And we'll look at kind of some of the indicators and then some of the supports. And I'm going to go through some of these slides a little bit quickly, but you'll have access to them. So you'll be able to look through them more in depth as you go. But one of the books I really appreciate is Brian Butterworth, 2019, and some of his research on the neurons and actually how the brain works in terms of understanding the differences in some of those numerical processings. And so as we look at this in learning about number concepts, there are a variety of ways that we can support students. But one of the things that we don't understand is how they develop an understanding of numbers. It's things from subitizing to categorizing. And you remember the picture of my colleague's young son on a Saturday morning, sorting and organizing and just having time to grapple with the ideas. When we look at that, I think that the low floor, high ceiling tasks are really helpful in gaining access to that information. And one of the things that we can do is to support kids kind of where they're at. And I want to tell you a quick story. This is one of my students. I asked her permission to show a picture of her hand and her iPad. But we were doing some calculations, and she's a fascinating, wonderful young woman, very, very capable, interesting, engaging, super cool kid. But it's fascinating to me. She really, really struggles with calculations. So she can factor quadratic equations. She understands imaginary numbers. I mean, we're operating at a high level, going through cool things. But when we come to factoring, for example, and I want, the factors of 24 or 12 or those types of things, she gets quite nervous and she's like, hang on, Dr. Adair, hang on. I'm like, no, you're doing great. Go ahead and grab your calculator. Let's walk through it. And so kind of with the technology and the support, she's able to access mathematics at a very high level, but without being drawn down by a calculation or computation that's challenging for her. I'll be interested and super excited to kind of learn through this year with her about kind of where she's at and how I can support, because I do want to attend to that information and those mathematical facts, because again, with that automaticity, her cognitive resources can be allocated for other things. At the same time, that can't be all we do. We got cool stuff to do. So that was pretty interesting. When we think about dysgraphia and kind of the handwriting component, thinking about more space on a page. How many workbooks have we seen, worksheets have we seen, where there's like no place to do your work? So I gave all my kiddos a composition notebook with graph paper in it this year, and I'm teaching them how to take notes and how to organize and how to use Frere models and things that are supports and strategies that allow them to be successful with their investigation of mathematics. The other thing I would say in terms of, we have lots of assistive technologies, speech to text, different ways to grab pencils. I mean, things that we can be helpful, but again, time for students to do the work is important as well. And one thing I would say about assistive technology is that assistive technology, and I'm sure I'm preaching to the choir here, should never do the math, right? I don't want a photo math that's going to do the problem. I want to change my questions. I want to maybe give them the question and the answer and talk about what's your journey, what's the process to get there. So some cool ways to do that for sure. So in terms of just minding the gap, thinking about how do we help kids, really thinking about what are the issues, collecting that data, observations, student reflections. I was in a class with my middle school kiddos the other day. We used Jamboard during a Google Meet, and we were placing numbers on a number line. And it was fascinating to me. This young man was putting his integers on the number line and just noticing that he's writing the numbers backwards and kind of talking through. The other thing we did on this activity, though, was we had sticky notes, and the exit slip for the day was what's your favorite time of year and why. And so, excuse me working to get to know my kids, even though they're in another building, I think is critical for sure. All right, so now we're going to just take a brief tour of kind of the Wessler Intelligent with the WISC-5, and we're going to look at just a couple specific areas. And would you in the chat just give me a yes or a no? Does your school use learning profiles? Do you kind of gain insight into educational evaluations to help you support students? All right, we'll get some of those answers in the chat. And we're going to just start with the first one, Visual Spatial Index. Oh, some no's in the chat, yeah. And wish you did. Super helpful. So the Visual Spatial Index, our definition is kind of that ability to perceive patterns and solve problems. And the subtest we're going to look at is a block design. And then what's the impact on mathematics? Problem solving, mathematical thinking, certainly decision making with multiple steps. So when we look at the actual subtest, the students are shown a 2D image, and they're given actual physical 3D blocks, and their goal is to make that figure. So a way that you can support this is certainly Fawn Nguyen does a great job with visual patterns. And so having kids write the next step, draw it on their paper, what happens in the 43rd step. So a terrific way to support that kind of work for kids that maybe are challenged in that area. When we look at the Fluid Reasoning Index, our definition there is the ability to use logic to solve unfamiliar problems. And so the subtest here, and everybody get ready in the chat, we're going to do another task. Our subtest here is called Figure Weights. And our impact on mathematics is understanding mathematical concepts and relationships, as well as algebra, deductive, and quantitative reasoning. So we're given this image, and I'll go ahead and let you, if you're feeling saucy, I'll let you answer in the chat which one is going to balance our scale there. See who comes up in the chat with an answer. Drum roll, please. All right, couple people coming in. All right, we are on fire. 2 is correct. Well done. And then we would take it maybe to 1 level higher. And so let me give you a minute on this one. We'll just spend a couple seconds here, actually. On this one, it's a more challenging problem, and students have to think about kind of transitive property, actually. Thinking about how does image 1 compare to image 2, and then how do I use that to get image 3. Oh, Solve Me Mobile, Jessica says. Oh, and some of my kids were playing Flow, an app the other day that seemed super fun. Has anybody played Flow? I got hooked on it the other night, late at night. All right, we'll keep going. So, a support for this area of cognitive development would be Estimation 180 with Andrew. Estimation 180 with Andrew. And thinking about kind of how many small vases will it take to fill the large vessel. Some good ones there, and kind of how would you answer that question? The next area that I wanted to just a huge shout out to Desmos Activities, Dan Meyer and his team, and our host, Lee. Yay, everybody go. Yay, Lee is a Desmos fellow and a certified presenter. But just some of the Desmos activities are great ways to help kids share their thinking, grapple with ideas. I'm super excited. Oh, Anthony in the chat says he loves Flow. I just heard about it. Desmos, some really nice activities. If you've not used Desmos, please, 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 as your number one takeaway from this evening, get on Desmos, use an activity. It's interesting, it's engaging, it's helpful. Lots of good resources out there. And just, text Lee, she'll help you out. Our working memory, thinking about our ability to maintain and manipulate information in the short-term memory. And so our test here is the digit span. And this impact on mathematics is numeracy, representation and one-to-one correspondence, those kinds of things. Some good questions in the chat. GeoGebra, another good one. Youngest that we've used Desmos with, we've used it in our elementary school, 5th graders, 4th graders. Maybe other people in the chat can share what their age is with Desmos that they've used. Some cool Desmos activities with number lines and such and representations. So the digit span is 3 parts. There's a forward, a backwards, and a sequence. And so the tester would read 238, and then the student would report back 2368, excuse me. Backward, I would say the number's 2183, and then the student responds backwards, and then in sequence, smallest to largest. All right, so in the chat, I'm going to give you a forward. Let me give you a forward, and I'll have you write on pencil and paper. See how you do. We're going to do just one of these. We'll do the forward, digit span. So you're not writing it down as I say it, right? You're no pencil yet. I'm going to say it. You remember it. Then you write it down. Good clarification. All right. 1, 4, 2, 8, 6, 9. Then you would write it down. We would do a different set of numbers backwards and then sequence. So pretty challenging and also pretty interesting. The other thing I did with my kids the other day was to figure out kind of their numeracy and a little bit about how they are doing. I asked them to draw a line just with 2 endpoints, don't care how long. On the left endpoint, put 0. On the right endpoint, put 10. And then tell me where 7 lives. And it was fascinating to see some of the students had it kind of where I would put it. And some of the students, it was like really a lot closer to 0 than I would have imagined. And so interesting to gain access to student, how they're thinking about things cognitively through those kinds of tasks. All right. The other one I'd encourage you to do, and we'll go through this pretty quickly, is a simulation from understood.org. When we use money to help kids think about information, that really only works if they have an understanding of the money, right? So if I said to you, hey, we're going to buy an apple and it costs 7 cents, tell me what coins, drag the coins over. I think we all pretty quickly would say, yeah, I'm going to take a nickel and 2 pennies. And so that's awesome because I think we have an understanding of that unit of measure in essence. But what if we change it and we say that a dime is 29 cents, a nickel is 7 cents, a penny is 13 cents, and a quarter is 34 cents. Now to get that same apple, not too tricky because I've got that nickel right at 7 cents. But what happens when I say we want to buy milk at 83 cents? Okay, go. How do you do it? So suddenly our information is different, and that way that we were attaching conceptual understanding, we now have to re-script that in a different way because maybe the technique we were using for a particular student is not working. And just so I don't leave you hanging, that's the answer we would need to come up with 83 cents for milk. All right. So some support for that area. The Math Learning Center has some good free apps, some good information there for sure. Our last one is the Processing Speed Index, and thinking about this is about output and performance. So I used to think, and thanks to my colleague, Mr. Ernewine, that processing was more how I take things in, and that's not generally what we're speaking of here. What we're really thinking of is kind of the output. So how am I able to produce? And so that ability to fluently deploy one's focus, one's attention to process information. And the subtest here is coding, and working with mathematical symbols is how this might impact our mathematics. And the coding, this was interesting in the instructions. It says 120 seconds, not 1 minute and 20 seconds. And so you have this list of symbols, and in 1 minute, the students are just simply copying. And so what happens when coding? And when we look at this, that can help us indicate what student support do they need as they're going through different areas of mathematics. You know, if we have written down the problem and present it in a way that then they're not having to copy and track. Or, you know, a good example, this is my first year at Denver Academy 5 years ago, and one of my students was like, Dr. Adair, you're asking me a question and I don't understand what you're meaning. And it's totally my bad, but I had part of a question on the front side of a piece of paper, and the second part of the question was on the back. And she didn't think to flip that over, and I should have had the entire question on one page. So really just thinking, what are the ways that we can set up our assessments or our discussions for students that help them to be successful. Support for this one, Annie Fetter, New York Times, What's Going On with This Graph is a nice one to kind of get kids thinking in a different way. I've seen this used really successfully by one of our middle school teachers. Pretty cool to see kids looking at those graphs. Certainly a lot to be graphed about now, for sure. Awesome. We are now looking at just how can we help students, certainly by embracing mathematics, sharing a positive attitude, promoting curiosity and thinking mathematically ourselves. Asking our kiddos, what do you notice? What do you wonder? What do you think? And it was super cool. Yesterday it was very cold in Denver. I was looking at my phone and it said -0 degrees. I'm like, what? How could they do that? I get into my Algebra 2 honors class this morning and one of my kids, he's just awesome. Super interesting, very concrete in some ways. And he said, Dr. Adair, that's just wrong. We got to fix that. Who are we going to talk to? And I'm like, what are you talking about? And one of his classmates said, oh, Dr. Adair, he's talking about 0 degrees. Did you see that on our temperature? And it was awesome. It was just so true to think about numerically where we at and just kind of creating that environment where kids can grapple with ideas. We could share our disdain for -0 collaboratively and collectively. But I thought that was super fun. The other thing that was interesting, I did this Desmos art project with my kids a couple years ago and just really appreciating their creativity, their talent. This young man did just a remarkable job with this Desmos art project, looking at an Aston Martin from the James Bond movie and realizing that the Fibonacci sequence is in play in the design. I mean, those are just cool things to share with kids. Super fun for sure. Thinking back just to a couple tasks, we talked about the 4 4s earlier, low floor, high ceiling. Some of the books that I think we've read are super helpful. Some things in the chat, some awesome sharing of some additional resources. Appreciate that very much. And then in closing, I want to take just a minute here, and I'd love for you in the chat to ponder one of these 2 questions. Either, what is one way you are promoting mathematical thinking with your students, or what is one way you're working to build relationships with your students? I'm going to give you a minute to type in the chat for us a reflection on either one of those questions. Awesome. Susan, thank you for sharing. Always take time to visit with students about personal life, things that they want to share. Oh, Terry, nice. I have a handout, how to get good at maths. Love it. So promoting that, modeling that, giving them an organizer that helps with that. Thank you for sharing. Making direct connections between numbers and my students' physical surrounding. Thank you, Philippe. Promoting math appreciation by using mind setting activities. Very nice. All right. Counseling. Appreciate that. So many ways to promote mathematical thinking to the real world, sharing mathematical thinking, visual representation. Awesome. Some great things coming in the chat. Sue from Boston sharing in private chats in a Zoom where they're able to see, let them know your conversations. Awesome. Well, I hope this has been helpful. It has been an absolute pleasure engaging with you all in the conversation. I look forward to continuing the conversation. I certainly appreciate Lee, your hosting, and everybody for taking time out of your busy schedules to be able to be a part of this conversation. It certainly has been my honor and pleasure. I really appreciate it. And I hope you all have a wonderful and safe rest of your week. And I'll turn it back to Lee. Thank you.
Yeah, thank you very much, Mindy. There was one question that just popped in the chat.
Great.
Is there a way to assess learning profiles in a systematic way? That was from Jessica.
Great. Jessica, what we do is because we're a school for students with learning differences, we actually do have our students have learning evaluations. But I think there are definitely some of these ways in a systematic way where you might go through the 4 that I highlighted here and look at some of those supports. with your students. And even as simple as I had a student the other day, we were trying to figure out kind of her computation in her number sense, and just drawing that line with a 0 and a 10, she placed the number 7 where like a 2 might be. So just some simple kind of things like that would be a good way to assess some of that information if you weren't able to do the more formal kind of full educational evaluation. Lee, were there any other questions I missed?
I didn't really see too many. There's a question about how do we access the slides again?
Good. There's let me hit the next slide. You can do that one of 2 ways. I've put them on my website, which is just mathsforall.drdair.org. But I also believe, Lee, are they in your? Will they be at the Global Math?
I can definitely put them up there as well. Yes.
Okay, and they're definitely on my website, which is on the slide right now. So this has been awesome. Thank you all so much. I appreciate it. It seems like there were a lot of folks from a lot of locations around the world. Super fun.
Definitely fun. Thank you, everyone, for being here tonight. And thank you for being so active in the chat. It's definitely a much more energizing experience than I've had in some of my chat rooms with my students lately. Yeah, so let me just let you know what we have coming up for next week. Next week, we have breakout rooms for teaching math with Teresa Wills. This is a recommended grade level K through 12. So if you are struggling a little bit with getting students to be as active in the chat as we were tonight, then I would encourage you to come out next week on November 3rd to hear from Teresa Wills. Thanks everyone for being here tonight. Have a lovely evening, afternoon, or morning, wherever you happen to be around the world.
Thank you.